Hey math fans, we're on section 5.6.2. Let's get started. When a series of rigid motions is performed on a triangle, the result is a congruent triangle. And when triangles are congruent, the corresponding parts are also congruent. But in this section, we're going to take a look of how there's a set of congruence criteria that lets us determine whether triangles are congruent with less information. In the previous section, we saw that when you say that two triangles are congruent, you actually have 6 pairs of corresponding parts that will be congruent. 3 congruent sides, 3 congruent angles. But one of the first things we're going to look at is that you can have just 3 sides be congruent and then the triangles will be congruent. You don't have to prove that all the angles are congruent. It will just turn out that those angles will be congruent. Also, if you take 2 sides and then you have a congruent corresponding angle in between the 2 sides, that's also sufficient information to conclude that the true triangles will be congruent. Before we move on, I want to take a look at that vocabulary word called the included angle. The included angle means it's going to be between the 2 corresponding sides. Notice how I have line segment AC is congruent to line segment DF. I also have line segment AB is congruent to line segment DE. And now notice how the angle is in between the 2 corresponding sides that are congruent. In the second triangle, we have an example of where the angle is not included. Notice there it says nothing about angle A and angle D there, which would have been the included angle. Rather, B and E is not an included angle. So another way you can prove 2 triangles are congruent is called angle side angle. Now notice how the side is in between 2 angles, so we'll call that the included side. So notice we have angle C, we have angle A, and then side AC is in between the 2. It's got to be in between the 2 corresponding angles. You have F and you got D, and then you got the DF is included in between the 2 angles. So to sum up, these are the 3 ways that we can prove that triangles are congruent in this section. We're going to be looking specifically at side, 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 angle, and angle, side, angle. Please be careful with the last 2. Make sure that the angle is included between the 2 sides and that the sides included between the 2 angles. Now, why do these work? Grab a ruler, grab a compass, grab a protractor, try to construct a triangle, and for example, I dare you to construct a triangle that has 3 congruent sides, and then try to make another triangle that has the same exact measurements and have it not turn out to be the same triangle. It just works out that way. And the 2 triangles will be congruent, meaning all their parts will also be congruent, including their angles. Finally, you have some common errors and misconceptions. I would say the biggest error is misidentifying the included angle or the included side for these last 2. Example 1, determine which congruent statement, if any, can be used to show that triangle PQR and triangle STU are congruent. Well, we can see that PR is congruent to SU, PQ is congruent to ST, and RQ is congruent to UT. There are 3 corresponding congruent sides. Therefore, we're going to use side, side, side as the reason why these 2 triangles are congruent. Example 2, determine which congruent statement, if any, can be used to show that triangle ABC and triangle DEF are congruent. We do have line segment DE is congruent to line segment AB. And we also have line segment DF is congruent to line segment AC. And I'm noticing we do have an included angle. It's in between those two. So therefore, I'm going to be using SAS as the reason for my congruent statement. And now I can say that triangle ABC is congruent to triangle DEF because of side, angle, side. Example 3, determine which congruent statement, if any, can be used to show that triangle HIJ and triangle KLM are congruent if line segment HI is congruent to line segment KL, angle H is congruent to angle K, and angle I is congruent to angle L. You know what? I don't see a picture, do you? I wonder what we should do. Oh yeah, draw a picture. So the picture doesn't have to be perfect. Just whatever picture you can come up with, just draw two triangles, HIJ and triangle KLM, and mark the pictures accordingly. Here I have two triangles, and I have marked the given congruencies that were mentioned in the problem. So let's take a look. What do we got here? We have triangle HIJ has line segment HI, and then that corresponds with a congruent line segment of KL, okay? And then we got angle H here being congruent to angle K, and then angle I and L. So I have two congruent angles and then one congruent side. The question is this an included side? And if the answer is yes, I can use angle, side, angle. And yes, that is a included side. So these two triangles are going to be congruent because of ASA. And that's going to do it for this section. We'll see you in class.